Welcome back everybody, this is our final straight line lesson. Feels like we've been doing this topic forever. Good news is not all topics are as long as the straight line in higher maths. For today's lesson, a couple of small things that I need to remind you / teach you about, and then we'll try and put everything together and look at answering some kind of tougher exam style questions. So the first thing I want to remind you of how to do, or teach you how to do, is prove that a point lies on a line. So I want to know, does the point 210 lie on the line with equation y equals 3x add 4? Okay, now to do this, all I'm going to do is I'm going to substitute 2 and 10 in instead of x and y. I've just got to be careful how I do this. What I'll do is I'll substitute 2 in instead of x. We'll do this calculation, and if the answer is 10, then the point lies on the line. If the answer is not 10, then it does not. So if I substitute 2 in there, I'll get 3 times 2 add 4. So 3 times 2 add 4 is going to equal 10, and that is the same. So yes, this does lie on the line. If I got an answer which wasn't 10, the answer would have been no. Okay, looking at an equation that's slightly different, this time say we've got equation 3y minus 2x equals 8, and I want to check if the point 3,1 lies on this line. Now this time I am going to substitute both x and y into this equation, and then we are going to see if it equals 8. If it does equal 8, then yes, it lies on the line. If it doesn't equal 8, no, it doesn't lie on the line. So if I substitute y is 1, x is 3, so that's going to give me 3 take away 6, which is going to equal minus 3. As minus 3 doesn't equal 8, remember it should have equaled 8, 3,1 does not lie on the line. So that's how you prove if something lies on a line or not. Right, let's try and put everything together what we've learned so far in this topic. Let's look at some kind of harder style questions. Right, first things first. The main thing you're going to be asked about is making sure you know how to do medians and altitudes in perpendicular bisectors. So that's the main thing. Part A, find the equation of the median BD. Part B, find the equation of the altitude AE. And part C, find the coordinates of the point of intersection. It wants to know where do these two lines cross. So we'll start with A, which is the median BD. So you need to try and remember how you would find the median. So we covered this fairly recently. There are a couple of steps for doing the median, and you need to remember how to do that. That's one of your jobs. So for part A, so the median goes from B to the midpoint of the opposite side. So I want to find the midpoint of AC. So that brings another thing. How do we find the midpoint again? Remember, we add together the x coordinates and half, and we add together the y coordinates and half. That will give me a midpoint of minus 5, add negative 3 is minus 5, take away 3, which is minus 8, divided by 2 is minus 4. Minus 12 add 6 takes me up to minus 6, divided by 2 takes me to minus 3. So there's my midpoint. Okay, so for my equation, I need the gradient of the line BD. Well, I know I've got that point that's on it, and we've also got point B that's on the line, which is 11 minus 8. So those are the 2 points that I'm going to use to do my gradient formula. So it's going to be gradient formula y2 minus y1 over x2 minus x1. So that's going to give me minus 8 take away negative 3 over 11 take away minus 4. So that will give me minus 8 add 3, which will take me up to minus 5. 11 add 4, which will take me to 15. 5 over 15, that would simplify to be 1/3, and this one is going to be a negative. So there's my gradient, my point. So I've got 2 points that lie on the line BD. I know what B is and I know what D is, so it doesn't matter which one you choose. I'm going to go with 11 minus 8. Equation. Fill in the information that we know. Y minus minus 8, so let's go straight to y add 8, will equal minus 1/3 bracket x take away 11. So we're going to multiply this by 3 to remove the fraction. Remember, I'll just leave the minus 1 there. Multiply out the bracket. Be careful where your negative numbers work, it's add 11 not minus 11. Take the 24 away from both sides. And our final answer for part A is that. Right, part B, we want the altitude AE. So remember, an altitude goes to the other side. It makes a right angle because it's perpendicular to the other side. So to do an altitude, we need the gradient of the opposite side, the perpendicular gradient, and then we can use point A. So first things first, I need to work out the gradient of the opposite side. So for my gradient, we're going to get the gradient of the opposite side, so it's going to be the gradient of BC, which will be minus 8 take away 6 over 11 take away minus 3. That's going to give me minus 14 over positive 14, which would simplify to be minus 1. So that's the gradient of the opposite side. That is not the gradient of the side that we want. We need the perpendicular gradient. So I need my little statement for perpendicular gradients. And then I need to find my perpendicular gradient. Turn it upside down, change the symbol. The perpendicular gradient would just be 1. The point, it is the altitude from A. I already know what A is. It's minus 5, minus 12. We don't know E. It's not the midpoint. We're not trying to calculate point E. We're going with A. Minus 5, minus 12. And that's my A and my B. And then we're going to go to the equation. Fill in the information. Y add 12 will equal 1 bracket x add 5. Multiply at the bracket. Well, you're timesing by 1 so it doesn't change. Take 12 off both sides. And there is my equation. Right. Part C, it wants to know where our two lines that we've just worked out will actually cross. So again, have a look at the picture. We've just worked out the equation of BD, we've worked out the equation of AE, and we want to know where those two things will cross. So my equation for BD was this, and my equation for AE was this. So this is when you're going to have to think a wee bit back to last year, National 5. How could we solve these two equations happening at the same time? Okay, I'm hoping that you remember simultaneous equations, because that's what we're going to do here. Now, simultaneous equations last year, you were used to doing something that maybe looked a little bit like this. And you had to solve like that. What we've got just now doesn't look like that. I could try and rearrange it so it does look like that, but there's no need. To do simultaneous equations, this method over here where you make the A's the same and then take them away from each other, that's called elimination. But we also have another method which is called substitution. This says y equals x minus 7. I am going to substitute that in there in place of the y. We've got another way of writing it. Y equals x minus 7, so that's going to go in there and replace the y. So I will get 3 bracket x minus 7, like so. I'm going to multiply out this bracket, and now we're faced with a basic equation that we will solve using balancing. So I'm going to add x to both sides, minus 13. I am going to add 21 to both sides, 4x equals 8, and then I can solve that, x will equal 2. Now I'm trying to find the point of intersection, which means I need an x coordinate and a y coordinate. I have the x coordinate, but how will I get the y coordinate? Well, I'm going to have to go back up to here. This equation tells me what y equals. So by replacing x with the number we've just worked out that it is, I can get the y coordinate. So I'm going to use the equation y equals x minus 7. I now know that x is actually 2. 2 take away 7 will give me a minus 5. So that means that the point of intersection, or PI, is 2 minus 5. If you are asked to work out where lines cross, you're going to use simultaneous equations to do this. Okay, that's the first example done. Second example. Find the equation of L1, the perpendicular bisector of PQ. Okay, so you need to remember how you do a perpendicular bisector. So for a perpendicular bisector, you want the gradient of this PQ line, the perpendicular gradient, and for the point that lies on the line, remember it's in the middle of PQ. It is the midpoint of PQ. Right, so first things first, we'll get the gradient. So I want the gradient of PQ. So it's a perpendicular bisector of PQ, so I need the gradient of PQ to start with. So using my gradient formula and using the 2 points that I've been given, that will give me minus 2 take away 4, 9 take away 3, which will be minus 6 over 6, which is minus 1. But I don't want the gradient of that line, I want the gradient of the perpendicular line. So I need my statement. Turn it upside down, change the symbol, minus 1 will change to positive 1. So the gradient that I'm using is positive 1. Right, the point. It is this point here, it is the midpoint of PQ. So midpoint of PQ, add together the x coordinates in half, 3 add 9, halved, add together the y coordinates in half. That will give me 3 add 9 is 12, half is 6, 4 add minus 2 is 2, half that's 1, and then I'm going to go for my equation. Fill in my information, so it's going to be y take away 1 will equal 1 bracket x minus 6, multiply out the bracket, add 1 to both sides. Remember your negative numbers work, it takes you to minus 5, not to minus 7. And that's part A done. Part B wants the perpendicular bisector of PR. The equation of L2, the perpendicular bisector of PR, is 3y add x equals 25. Sorry, I misread the question there. Right, let's try that again. The equation of L2, the perpendicular bisector of PR, is 3y add x equals 25. So they have just told me the equation of that line. Part B, calculate the coordinates of C, the point of intersection of L1 and L2. Okay, they want us to work out where these two lines cross. we need to use simultaneous equations. We need to use the equations of both the lines. Now, part A gave us the equation of the line L1. The equation of line L2 they have given us here. Okay, so let's have a wee look at how we would do that. So I have my answer from part A, which is y equals x minus 5. That's the equation of the line that we're using. And then we have the equation of L2, which they've given us, which is 3y add x equals 25. Again, I've got two equations happening at once. I'm going to solve them using simultaneous equations, but again I will use the substitution method because this says y equals x minus 5. So that is going to substitute in there. So I'll write this out. 3y, well it's not y because it's been replaced by x minus 5, add x equals 25. Multiply out the bracket. I'm left with a simple equation that I just need to solve. I've got 3x add x, so 4x minus 15 equals 25. I will balance this by adding 15 to both sides. 4x will equal 40, so x must equal 10. I have the x coordinate, I want the y coordinate. This equation up here will tell me the y coordinate. Substitute the 10 instead of the x. Y equals 10 minus 5, which is 5. So the point of intersection is the point 10, 5. Okay, let's try another one. In fact, let's see if you can do this one. Ignore this dodgy picture. Right, part A. Find the equation of the perpendicular bisector of BC. That's the dotted line that I've drawn in for you. I want the equation of the dotted line. Part B. The line AB makes an angle of 45 degrees with the positive direction of the x-axis. Find the equation of AB. It wants the equation of that line. You should know how you're going to get the gradient because it tells you that the angle is 45 degrees. Remember back to how we did that. Part C, it wants to know where these two things will cross. Okay, press pause, give it a go, let's see what you've got. Right, part A. The perpendicular bisector of BC. So for a perpendicular bisector, I need the gradient of BC, the perpendicular gradient, and I also need the midpoint. So let's start with gradient. So I want the gradient of BC, which is going to be minus 2 take away 0, 9 take away 3, that's going to give me minus 2 over 6, which would be minus a third. I want the perpendicular gradient, so I need my statement. Turn that upside down, change the symbol, it will give me 3 over 1 or just 3. For the point, I need the midpoint of BC. So add together the x coordinates in half, add together the y coordinates in half. That will give me 12 over 2, which is 6, minus 2 over 2, which is minus 1. So there's my point, and then I can go to my equation, and then it's going to be y take away minus 1, or y add 1, will equal 3 bracket x minus 6, multiply out the bracket, take 1 away from both sides. Final answer, y equals 3x minus 19 for the perpendicular bisector. I hope you all got that right. Right, part B. It wants the equation of the line AB. Remember, for the equation of the line we need the gradient and we need a point. It's this line here. We've got a point, we need the gradient. It tells us that the angle is 45 degrees, so that's how you're going to go ahead and do it. Okay, so for my gradient, you're going to go m equals tan theta. That's the formula we're going to use when we know the angle. So it's going to be m equals tan of 45. So at this point we haven't covered the trig unit, so I would expect most of you will have to dive to your calculator and do tan of 45. When we go through the trig unit, we will go back over this in greater detail and show you something called exact values. So if you use your calculator, tan of 45 is going to give you a gradient of 1. Point, well, it's the equation of line AB. We already know the point that lies on the line, 3, 0. Equation fill in your information. Y take away 0 will equal 1 bracket x minus 3. Y take away 0, well that's just y, multiply at the bracket, and we're straight to the answer. Part C wants to know where your two lines will cross. So you have this line from part A, and you have this line from part B, and we want to know where they cross. We want to solve them simultaneously. So same as before, I'm going to use substitution. Y equals 3x minus 19. That's going to go in there instead of the letter y. And we get a basic equation that we're going to balance and solve. So I'm going to take x away from both sides. Remember here, when the x goes, you're left with minus 3. Don't change that to positive 3. You need to be careful with the symbols. I'm going to add 19 to both sides, and then x will equal 8. To get the y, now both these equations say y equals, so I can choose either of them. I'm going to go with the easier one. Sub the x in, which is 8, so y is going to equal 5. So the point of intersection is going to be 8, 5. Just like so. I hope you got it. Right. Last one that I'm going to get you to try, and then we can wrap this whole topic up. Here we go. A part 1. You're going to state the coordinates of M, the midpoint of QR. Part 2, hence find the equation of PM, the median through P. Part B, find the equation of the line L passing through M and perpendicular to PR. Now you will notice that that doesn't appear on the picture. That's okay. If you wanted, you could draw it in, but you don't need to. Find the equation of the line L passing through M and perpendicular to PR. Part C, show that the line L passes through the midpoint of PR. Sorry, I'll just move that down. Okay. Hit pause. Let's see if you can work this out yourself. On you go. Right. A part 1. It wants the midpoint of QR, which is going to be point M. So midpoint, add together the x coordinates in half, and then do the same with the y coordinates, add them together in half. So that will give me minus 6 add 10, which is 4, half is 2, that's 8, divided by 2 is 4. So nice and easy to start with. M is the 0.24. Part 2. Hence find the equation of PM, the median through P. So it wants the median through P. We now know that M is the 0.24. So we've got all the information we need. We want to find the equation of the line PM. So gradient, I've got both points there, so I can just use my gradient formula. So it's going to be minus 4 take away 4, 0 take away 2, which will be minus 8 over minus 2. Minus 8 divided by minus 2 will give me positive 4. Point, I've got 2 points that lie on the line. I'll go with the 0.24 because it's a nice and positive point, AB, and then my equation y take away 4 equals 4 bracket x minus 2. Multiply at the bracket, 4x minus 8, add 4 to both sides, y equals 4x minus 4. Job done. Right, B. Find the equation of the line L passing through M and perpendicular to PR. Okay, so it's not been drawn for us on here. So it's perpendicular to PR, so crosses at a right angle and goes through the point M. So it would look something like that. You're having to find the equation of this line here. So like all lines, we need a gradient and a point. We've got the point M. How will we get the gradient? It's perpendicular to PR. I need to get the gradient of PR, then the perpendicular gradient. You're basically doing a perpendicular bisector-ish, but we're using that point up there. So first things first, I want the gradient of PR. Which will be 6 take away minus 4, 10 take away 0, which will give me 10 over 10, which is 1. That's not the gradient of our line. That's the gradient of that line. Our line's this one, so I need a perpendicular gradient. So my perpendicular gradient, turn it upside down, change the symbol, would be minus 1. Point, well, the line goes through point M. Equation, camera malfunction, where are we? Major camera malfunction. Equation, fill in the information that we've got. Y minus 4 equals minus 1 bracket x take away 2. Multiply out the bracket. Be careful of your negatives. Add 4 to both sides. Y equals minus x plus 6. Right, the last thing it wanted, it says show that the line L passes through the midpoint of PR. Okay, now do we have the midpoint of PR? What is the midpoint of PR? Well, then to show that this line passes through it. So the first thing I'm going to do is I want to work out the midpoint of PR. So midpoint of PR, add together the x coordinates and half, add together the y coordinates and half. So 0 add 10 halved, minus 4 add 6 half, that will give me 10 over 2 which is 5, that's going to give me 2 over 2 which is 1. So I need to prove that this line goes through this point. So we covered that right at the start of the lesson, so I'm going to substitute 5 in and the y value should be 1. So there's my equation. If I substitute x in, what do I get as the answer? As it's the same, the 0.51 lies on the line. And that, people, is the end of the straight line unit. Hope you enjoyed it. We'll be back soon with more.